So today the objective of this video is to talk about the scientific method. What is science? The scientific method is a set of tools that we have to figure out and understand what is true and what is not, or better said, what is more likely to be true than what is not likely to be true. So we want to understand phenomena on the natural world, and we want to evaluate what are the causes, what is the causality behind this phenomenon. Yeah. So we have the science in general, scientific method works under the assumption that we have only actually two real mechanisms behind everything on the world. The first mechanism is causality. Yeah, one thing causes the other, this cause and consequence. And the second one is some level of randomness. So randomness could be something that is inherently random, or it's just that we don't know enough about the causalities behind all the interference that in this chain of unknown causalities is causing randomness on the data. So, you know, how science works in the basic description is first you have observations of the real world. Based on these observations, you set an hypothesis, which is an idea of what could be working behind this observation. And then after you have this hypothesis formulated, you design an experiment to evaluate if this hypothesis is really likely to be true or not. Yeah? So this been going on. This is a natural process that humans have been using for even millennia for trying to figure out what is happening on the world. But these scientists from this last century have been organizing these ideas a little bit more in the field of science, of philosophy actually, that is called epistemology. Epistemology is dealing how do we know that we really know something or we don't know something. So epistemology is like the philosophy of knowing, the philosophy behind knowing or not knowing. Yeah? And science is a set of methods that deals with this knowing or not knowing. Okay, so one key author that is responsible for organizing this hypothesis testing method of science is an author called Karl Popper, and his book, which is called Logik der Forschung in German, and that translates for Logic of Research. And he sets up that there are two main criteria that we identify with if something is really scientific or unscientific, is that it's, the hypothesis behind the statements are really, they need to obey a criteria of falsifiability and testability. Yeah, you need to be able to refute that statement that you have as your hypothesis. Okay, so if you cannot test it, if you cannot refute that statement, that is not a good hypothesis for science. So a hypothesis must be able to be tested and rejected. All the other statements that are not testable, they're not in the field of scientific knowledge in general. And some things in science, they become fuzzy a little bit. For example, in my area, whenever people talk about soil health, for example, it becomes a little bit subjective. What is the concepts behind? And science is always dealing with objectivity and ways of quantifying different parameters to be able to test this hypothesis. So the two ways of doing that in science is, first of all, we have to be reductionists. We have to isolate what we are testing. If we look at everything together, it's really hard to tell what is happening. So if you have many confounding factors happening at the same time, it's very hard to isolate what is the causalities behind what is happening. So we need to reduce for simple questions, simple statements, in a way that we can isolate these factors in a very simple experiment that will be give more information about what is happening on the system. So this, and whenever we use this reductionism, this is always accompanied by mathematics, and we can calculate the probabilities of that results that we observe confirming or rejecting the hypothesis that we have formulated. Okay, so a good hypothesis will be specific, will be reductionist, it will be testable, and will be falsifiable. And then you can accumulate data that you will measure on the experiment testing that hypothesis, and that data will indicate clearly if your hypothesis is accepted or rejected. Yeah. So the statement of a hypothesis comes from sort of something like, if this happens, then that will be the result of it. Yeah. So if then is what you have to think about, and then within that statement you have to think that your hypothesis should not be very broad. It should be based on some previous knowledge, on and previous assumptions that are logic, and you have a pretty good idea, a good guess of what could be happening, and your hypothesis actually, it will be formulating that idea that you think it's likely to be true. But actually how you test it, is the important thing. Is you want to verify that that the hypothesis, if the hypothesis could be false, yeah, you try to falsify your hypothesis. So when you design your experiment, you try to find ways and prove that your hypothesis is wrong, and when you don't find that way, then you assume that it's likely to be true. So if you let's say if I make a simple statement that all bacteria are, for example, below 10 micrometers, because this is what I usually observe. If I run the experiment just to show that I find more microbes at this size, I'm actually not proving anything. What I need to make an experiment to try to find the microbes at bigger sizes than that, and if I do find bigger size, then I reject my hypothesis. So the experiment and hypothesis testing is always related to trying to find the conditions where your hypothesis fail. You want to falsify your hypothesis, and then when you cannot do that, then you accept your hypothesis. So one of the important things in hypothesis testing also is whatever hypothesis you're currently assigned that is likely to be true, it doesn't mean it will always be accepted like this. It has further experiment, further evidence can give it a better idea, falsify your hypothesis on the future, and then this better idea could be the new knowledge. Yeah. So science is always a work in progress. It's not something that you will always say that something is really true. It's just your best guess at the moment, but it's not just a guess. You can calculate actually the probability based on the data that you have. What is the probability of that hypothesis being accepted or as a true statement or not? Yeah. So this is actually what I wanted to elaborate about hypothesis testing. And this, of course, hypothesis testing is something that is related to the problem statement and the question formulation of your research. And then when you have an interesting question, that makes your hypothesis also a good hypothesis. So you should try to make a question that is based on previous knowledge, and a question that is specific, and a question that is it can be tested, yeah, to give an answer for it. And the most likely, the best guess of an answer that you have for that question, that is your hypothesis. So when you do hypothesis testing, that is what you have to basically consider. We're trying to find the cause effects, the causality behind, and the initial way of doing this is formulating your questions, and your best guess would be the answer of that question, and based on that you design your experiment to try to falsify those hypotheses. And if you cannot falsify, then you accept them. All right, this is all I have to say about this. Thank you.